Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 9 from the January 2024 International A-Level Edexcel Pure Mathematics P2 paper. And here we have a question about trig equations. Again, this statement, solutions relying entirely on calculator technology are not acceptable. So you cannot just write down the answer for these questions without showing any steps. You have to show how you got to the answer. So it says solve for x between 0 and 360 degrees, so degree mode. 0 is included, so take care of that. There might be some relevance to that, okay? And 360 is not included. That also might be some relevance to that. So take care of the limits here. Okay, so we want to first rewrite this in such a way that we can solve this problem. Okay, now we cannot use we cannot say, like some people say, either sine x equals 5 or tan x equals 5. That won't work, because that will only work if it says equals 0. You have the 0 product property, because when two things multiply to give you 0, one of them must be 0. When they multiply to give you 5, you cannot say one of them has to be 5. If they multiply to give you 0, then yes, one of them must be 0. So we cannot go down that route like some people might try to do. We have to rewrite this in a way that we can now solve it. So the only thing really that we can do here, if we look at this question here, is we can say, let's use identity that tan of x is equal to sine x over cosine x. Okay, so I'm going to take the sine x and leave it as it is. The tan x, I'm going to write it as sine x over cosine x. Okay, so I haven't divided by cosine x. I have just rewritten tan x as its equivalent as sine x over cosine x. That will help us now, because I can see I've got now sine squared x over cosine x equals 5. And now what I can do is I can multiply both sides by cosine x. So I have sine squared x equals 5 times cosine x. Now I have these written in forms which I can now try to rewrite. So I know that sine squared x can be written in terms of cosine squared x. The one that's squared can be changed, because we know that sine squared x plus cosine squared x is equal to 1. So I can take the sine squared x and I can replace it with 1 minus cosine squared x. Don't make the mistake of thinking that this applies to them if they're not squared. I cannot say that sine x plus cosine x equals 1. It's not true at all. Okay, so some people will say, sir, but why you took the, if you take the square root of both sides, won't you get this? No, you won't. Okay, because there's two terms here. Just like I know that 3 squared plus 4 squared is equal to 5 squared. All right, if you take the square root of both sides, you don't say 3 plus 4 equals 5. No, you have to say the square root of 3 squared plus 4 squared equals 5. Okay, you can't take the square root of them individually. All right, so sine x plus cosine x does not equal 1, which means we cannot change this cosine x to 1 minus sine x. No, but if it's squared, you can change it. So the sine squared x can be written as 1 minus cosine squared x. That's equal to 5 times cosine x. I don't, in fact, even need the bracket in this side here now. Okay, and now I'm ready to try to rearrange this in a way which I can solve. I can see a quadratic here. So what I'll do is I'll put 0 on this side. I'll say cosine squared x plus 5 cosine x minus 1 equals 0. Just added this to both sides and subtracted 1 from both sides. So now I have something which is solvable. It's a disguised quadratic in cosine x. Okay, so I can say, for example, to make it be more familiar, let, for example, u equals cosine x. That means u squared will be cosine squared x. So I can rewrite this as u squared plus 5u minus 1 equals 0. So I've got to find two numbers that multiply to give you minus 1 and add to give you 5. Well, there's no way you can find that. So this cannot be solved by using factorizing. We have to try to, for example, complete the square, or to use the quadratic formula. Now, if we complete the square here, we have u squared. Let's see if I've done something silly here. I don't think so. Added that, subtracted that. Okay, good. So now we got u squared well, plus 5u is equal to 1. That's the first step. Then we're going to have u plus 5 over 2 squared minus 25 over 4 equals 1. Okay, so I'm completing the square for this. So I'm taking half the coefficient, squaring the bracket, taking away the square of what's inside here. So we have u plus 5 over 2 squared is equal to, that's 4 over 4 plus 25 over 4, which is 29 over 4. Okay, and then we can take the square root of both sides. So u plus 5 over 2 equals plus or minus the square root of 29 over 2. So therefore, u is going to be minus 5 plus or minus root 29 over 2. Those are the two solutions. So we can say that the cosine of x can either be plus root 29 over 2, or the cosine of x can be minus 5 minus the root of 29 over 2. Now, I suspect that this will have no solutions because its value is going to be less than minus 1. We'll see. So let's see what happens to this when I put this in my calculator. So x is going to be the inverse cosine of minus 5 plus root 29 over 2. I think this should give us some solutions. Let's see. So we got to make sure we're in degree mode. Which we are, I think. Yes. So we're going to do inverse cosine of, in brackets, well, we've got the brackets, so we can put minus 5 plus the square root of 29 over 2. Okay, so that's going to give us 78.896. So x equals 78.896. That's the first solution. Okay, and now for the cosine curve, to find the other solutions, we do 360 minus this angle. So 360 minus 78.896. So I'll just keep this in my calculator here and do 360 minus this, which gives us 281.104, 281.104. Now we want to find the solutions from 0 to 360 degrees, and there will be no other solutions apart from these two, because if you add 360 to this or this, you're out of the range. If you take away 360 from these, you're out of the range. For the cosine curve, you have your calculator answer, you have 360 minus your calculator answer, and then they repeat every 360 degrees. You add and subtract 362 and from these angles, which in this case will take us out of the range. So those are the answers from this particular section. I'll write down the full answers at the end if we have any more. So let's see what happens when we try to do this. I'm suspecting it's going to be a maths error. There's no, let's actually take this back. Okay, let's go back to this and change that to a minus. That's going to be, I think, yeah. Okay, because the value of this part is going to be something which is less than minus 1. So there's no solution to this. Okay, so these are the two solutions. So we can say x equals 78 points. Let's see what they ask us to do. 1 decimal place. Even if they didn't say 1 decimal place, that's how we should give it, unless otherwise stated. And that's 281.1 degrees. Those are the two solutions to this equation here, using, the two very important identities that we should know. Okay, these two identities are very, very important for us to be able to solve such equations. Okay, so you have to rewrite it in a form that's easy for you to deal with. All right, so there's the answer to question number 9, part 1. Now for part 2 of question number 9. Here we're given a curve, looks like a trig curve. It says figure 1 shows a sketch of part of the curve with the equation y equals a times sine of 2 theta minus 3 pi over 8, all in the bracket, plus 2 outside the bracket, where a is a constant and theta is measured in radians. It says the points P, Q, and R are points on the curve and are shown in figure 1. Given that the y-coordinate of P is 7, so this is 7, so you can say this is x, P, and 7. We don't know the x-coordinate, but the y-coordinate is 7. States the value of A. All right, so now this is not too difficult to do. It's only worth 1 mark. It just says state, but I'm not just going to just write the answer down and go ahead. I'm going to explain to you the thinking behind or the thought process behind getting the answer. So steps don't need to be shown for this part of the question, okay, because it says state, and it is something, if you understand it, it's pretty straightforward, but some people might have a difficulty to understand what to do, so I'm going to go through the process. So we can see, if we look at this, that in terms of vertically, there's 2 things that affect the vertical or the y coordinates, which is the vertical stretch, which is when you multiply the whole function by something, and the vertical translation, where the whole thing has shifted up by a factor of, or by 2 units upwards. Okay, so basically what's happened is 2 things. Vertically, what's happened is 2 things. Horizontally, something else happened, but vertically, this is what's happened. Okay, vertically, the first thing that happened vertically was it was stretched by a factor of a. Okay, so you say a vertical stretch. Okay, scale factor equals a. We don't know what it is, but that's what we have to find. And the second thing that's happened is a translation vertically, and the vector will tell us that it's vertical anyway. Translation of vector 0, 2. Okay, so that's what's happened to, okay, the coordinates of P. Now, P, normally, it's in the normal curve, if it was y equals sine x, the original position of P, it would have been where P first reaches its maximum. That would have been pi over 2 and 1. 1 would have been where it was vertically. That's a maximum in the sine curve. So after the transformation, what's happened is that 1 has been taken, it's been multiplied by the stretch factor a, and then 2 has been added to it, and it ended up being at 7, the y coordinate. So the y coordinate was multiplied by a first, and then 2 was added to it, and you ended up with 7. So you can see a is going to be 7 minus 2, so a is going to be 5. So we can see that a is equal to 5. The question just says state the value of a, so you don't really need to show those steps, but just to make sure that everyone understands, I have, mentioned them up here. This is basically the logic behind it, okay? And then it says give the coordinates or find the exact coordinates of Q. Now, Q is a place which, if we think about y equals sine x, it's going to be the first place where you have a minimum. All right, so in the original sine curve, the origin of Q would have been, the y coordinate would have been -1, and the x coordinate would have been 270 degrees. If you know the sine curve, it goes like this. The first time it reaches the minimum is at 3 pi over 2 in terms of radians. So the coordinates of Q, what's happened to Q? So let me just, the origin of Q would have been 3 pi over 2 and -1. So what's happened to Q? Horizontally. Okay, horizontally, what's happened? Let's look at the transformation horizontally. So we can say horizontally, what's the transformation that's taken place? First thing, it's inside the function. So it's like f 2 theta minus 3 pi over 8. So when you're going horizontally, you first start with the opposite of BIDMAS. So we're going to start with the minus 3 pi over 8. Okay, so that means it's going to be a translation of the vector. It's going to be to the right 3 pi over 8. That's the first thing that happened. And secondly, what's happened to it? It was a 3 pi over 8, 0, sorry. 3 pi over 8, 0 to the right. Second thing, you're going to have a horizontal stretch. And the scale factor, sorry about my bad writing here. Scale factor is going to be a half. It's always the opposite. So you have a horizontal stretch. Let me write that a bit better. So you have a horizontal stretch. Scale factor a half. Okay, so those are the 2 things that happen. So 3 pi over 2, first thing you do is you add 3 pi over 8 to it. And then you multiply this by a half. That's going to give you the x coordinate of Q. This is going to be the x coordinate of Q. Okay, so the x coordinate of Q is going to be when you add these together, you're going to have times 4 and times 4. That's going to be 12 pi over 8 plus 3 pi over 8. And that's going to be multiplied by a half, which gives you 15 pi over 8 times a half, which is 15 pi over 16. So the coordinates of Q are going to be 15 pi over 16, I should say, over 16. That's going to be the x coordinate, and we need the y coordinate as well. And we already worked out what's going to happen to the y coordinates over here in the top here. It's going to be multiplied by a. So for the y coordinate of Q, it's going to be multiplied by a. So the y coordinate starts off as -1. You're going to multiply by a, which is 5, and then you're going to add 2 to it. So you're going to end up with the y coordinate of Q is going to be -5 plus 2, which is -3. So that's going to be -3. So these are the coordinates of Q. Okay, these are the coordinates of Q after, you can think of the transformation of the sine curve. Okay, that's one way of doing it, using transformations. Okay, so those are the exact coordinates of Q. That's part B done. And now for part C, it says find the value of theta at R, giving your answer to 3 significant figures. So now we've got the equation of this curve, and R is where it hits the x or the theta axis. So at R, y equals 0. Y equals 0 at R. Okay, so we can say that 5 times the sine of 2 theta minus 3 pi over 8, close bracket, plus 2 is equal to 0. So we can rearrange this. We're going to have the sine of 2 theta minus 3 pi over 8 is equal to -2 over 5. So we can find the inverse sine of this. Okay, the inverse sine of -2/5 is going to be given, we can say, let's just do it properly. We can say 2 theta minus 3 pi over 8 is going to be given by inverse sine of -2/5. Now we have to be in radian mode here. So let's put this in radian mode, shift angle unit to radian mode. So inverse sine of -2/5. Okay, that's going to give us a negative answer, of course. It's going to give us negative 0.4151. So that's going to give us, we'll say 2 theta minus 3 pi over 8 equals negative 0.4115. 0.41151. Okay, I'm going to store this as A in case I need to use it again. I probably will have to. Okay, so that's the principal angle. Okay, to find the solution that we're looking for. Okay, we're going to have to do something here because we know basically what we found here is this angle over here. Right? That's what we've just found. Inverse sine of -2/5. No, in fact, it's not even this angle over here. It's as if we got the sine curve for now, and then we're going to do the adjustments later. So we found an angle. It's like we've used the sine curve by doing this inverse sine. So we found an angle over here. We want to find the angle that is in this position. Okay, so we're going to do pi minus this angle. So we say 2 theta minus 3 pi over 8 is equal to pi minus 0.41152. Okay, so we're going to do pi minus this. So we have pi minus the last answer. That gives us the first angle. So that's going to be 2 theta minus 3 pi over 8 is going to be equal to, as we just found, 3.5531. 3.5531. So this is the calculator answer. This is called the principal solution. And this is the first main answer. Okay, so when I solve for theta, what's going to happen is when I add 3 pi over 8 to this and divide by 2, that's going to give me the first angle over there, right? That's going to give me the first angle over there. And we can see that that will give us the first angle over there. Hopefully it will be a positive angle. Let's see what happens when I do that. Let's go back to the first angle which we found, which was this angle. If I add 3 pi over 8, so if I add 3 pi over 8, okay, to that, and then I divide that all by 2, that gives me, that's the first angle over there. What I'm looking for is this angle over here. So I've got to take the second angle I found, which is this one here. Okay, I'm going to take this angle here, and I've got to find the next place where that occurs, which is going to be 2 pi after this. See, after this, it's going to be the we're gonna find the fourth angle. So the first angle we get leads us to this solution. Okay, and the second angle, and then if I add 360 to that, it's going to lead me to that solution. But the second angle we get, the second main angle we get, will lead us to this solution. And if I add 360 to the second angle we get, it will lead us to the solution we want over here. So we're going to take this angle here, and we're going to add 2 pi to it. And it will give me the angle I need to give me what this is once I've rearranged. So I'm going to add 2 pi to this angle over here. So if we go back to what we got here, this was, let's go back to what we got. Okay, this was the angle A. If I do 2 pi, first of all, I did, to get the angle I wanted, I did pi minus this. So you're going to have pi minus the answer. That's the angle that we got. And if I add 2 pi to this, this is going to give me what I'm looking for, which is 9.8362. Okay, so I'm going to store this as B. So we have 2 theta minus 3 pi over 8 equals, and this is the angle I'm actually looking for, 9.8362. 9.8362. This is the angle I'm looking for. This is the angle which is going to lead me to the fourth solution. I'm looking for basically, the fourth time this, hits what I need. So basically the fourth time is going to be over here somewhere. So it's going to be the angle we found here, 2 pi more than that, and that will lead us to the solution we're looking for here, which we found by just rearranging this for theta. So we have 2 theta equals 9.8362 plus 3 pi over 8, and then divided by 2. So we're going to take this answer, we're going to add 3 pi over 8 to it. So add 3 pi over 8. Okay, and then divide by 2. So that gives me 5.5071, 5.50, 5.50, what was it? 719. 719, it goes on. So now we can round the answer to 3 significant figures. So theta is going to be 5.51, and that's the first time. That's going to be with this curve hits this the fourth time. So when we solve this equation, inverse sine of minus 2/5, we're finding where this, basically we're finding this angle here. Okay, so we're looking for, this angle here, this answer here. When we rearrange this, leads us to the solution that we're looking for. The solution that's over there. That's not what we're looking for. What we're looking for. We're looking for R, which is the fourth time that it's going to touch the theta axis. So this angle here leads us to the second time. Okay, and there will be another angle over here which leads us to the third time, and this angle here leads us to the fourth time. So this angle here is found by adding 360 to what we found over here, adding 2 pi to that. So to find this angle here, the calculator gave us this answer, 180 minus 8 gave us that answer, and 360 more than that gave us the answer we need to give us this solution. Okay, so we took that and we added 3 pi over 8, and then we divided by 2, and we got that solution. Okay, so there's the answer to question 9, part C of the January 2024 paper. I hope that was clear. Other questions from this particular paper can be found in the playlist that will be showing over here at the end of the video. Other questions from the topic of trig equations, okay, can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and here the video that will takes you or shows you how to use my channel to find what you're looking for. Thank you for watching and see you soon.